In this session, we'll get familiar with the concept of caching in GitHub Actions, and we'll learn how to create and use it. As you can see, there's a separate tab for caching where we can see the list of files that are being cached. At this stage, we don't have any files, so we can't see them. Before we start the lesson, let me show you an example of where we can use caching. I have a starter theme, which means separate repositories that I use when I start building websites on WordPress. It doesn't matter how this project works. What's important is that it uses NPM. So pay attention, in Corn there's a JSON package, and this JSON package contains a number of dependencies. And of course, we don't have the Node.js folder in our repository. So you understand that in order to compile the source code that I could copy to the production server, I need to run certain commands. So I need to install all these dependencies, run npm install, and then run various commands for the build. Let's take a look at the workflow of this project. Everything here is commented out so that the workflow doesn't run if I'm editing any files. After all, this is a starter theme, it's not a project. We're interested in the section with the steps. I want to go through them and show you something. So the first step, we're specifying that we want to use Node.js in our project. So we use uses and action setup Node.js. In cases where we need a specific version, we pass additional parameters. I'm specifying that I need version 12 for this project. So this step will set up Node version 12 on the virtual machine. The next step is that I clone the repository onto the virtual machine. You did this in the previous lessons too. And the next step really interests me. After I've cloned the entire repository, I need to install all the dependencies. So I'm running the command npm install. And this command will start installing all the dependencies from package.json. And as you understand, there are different projects. And this installation takes anywhere from a few minutes to several tens of minutes, depending on how many packages we have being used. After this step, we'll have to wait about 3 to 4 minutes after the full installation. And then we run the command that compiles the files and creates the source files. After that, I use an additional action to send these source files to the server, to the production server, and everything would look logical except for one step. Except for this step when we create this nodes folder, because every time we run this workflow, it will download, and create this node modules folder. And imagine that we made some push, and after 5 minutes we have to fix a small mistake, like a letter in the code. We fix that, push again, and the installation of those dependencies starts up again. So for this step, we can create a cache and just refer to that cache when we access it again. If there's a need to edit the source files every 10 minutes, then this workflow simply won't install them, but will take the necessary files from the cache. That's what we'll be doing in this lesson. We're going to work with two actions. These are action cache and action setup node. I'll also include links to them in the lesson. And we'll also be using our repository that we've been working with up to this point. The only thing is, let's simulate it and set it up in a way that we can use it for the current lesson. So we'll create a package JSON and install some dependencies. So we're going to create some kind of simulation. So let's initialize npm first. I'm opening the terminal in this project and typing the command npm init. Great, the package JSON has been created. Next, let's install a dependency. I'm going to install Axios. Great. And now I need to create a jitinure so that this node modules folder doesn't get sent to the server. We need to create the file in the root. And I'm writing node modules in it. At this point, we are going to focus on developing the workflow process. The first step is to initiate the creation of a brand new workflow. During this process, we will assign a specific name to it, which will be used whenever we execute it. This workflow can be configured to activate either when there is a push event or when it is manually triggered by a user. By doing so, we ensure flexibility and control over how and when the workflow is executed. Let's go with push, so we don't have to click buttons unnecessarily. and we specify the jobs, it will run on push. And we'll specify the steps we need. So, in the example I showed you, we used an action to set up Node.js. This was done because I needed a specific version, the 12th version. In this case, I don't really care what version it is. It will work for me in the latest version, so I'm just skipping this step since Node.js is already installed on the virtual machine. We confirmed this in the previous lesson. So I'm going straight to copying the repository files to the virtual machine. I'm doing this using the checkout action. And as you remember from the previous lessons, the current version is the 4th. In the next step, we'll be caching Let's call it cache node modules. This process involves naming it cache node modules, which will serve as a reference point in our workflow. We're going to use the action cache, which is a crucial component. The action cache is an essential tool that plays a significant role in optimizing our operations. We need to pass the following parameters to ensure proper functionality. Additionally, we need to specify the exact path where the current cache is stored for accurate retrieval. Ensuring the cache is accessed correctly and efficiently is vital for maintaining system performance and reliability. In Linux, it's stored at this path, and we need to set a name for the file, which is the key that will be used to find this cache file later. In this key parameter, which is absolutely crucial and very important for the operation, I need to set a name for the cache file, so we specify its cache file. Now, in the next step, let's display the cache to make sure there's something in there. We're basically using the run command, and essentially echo, we're writing an expression. And in the expression, guys, we need to refer to the context of the steps. Next, we need to refer to this step that creates the cache, and it will return an output. To access it, it needs to have an ID, so we set an additional ID, and then I can specifically refer to this step by that ID. I'm interested in its output key, and in this key, we'll find what this step that creates the cache returns. The next step is to install our dependencies. We're running the command npm install, and basically that's it. Let's run it and see what we get as a result of executing this workflow. And by the way, we'll have to run it several times. So we'll replace push with workflow dispatch, so we can trigger it manually right on the site. And now we're pushing. And we commit these changes. Let's make sure we turned off everything from the previous lessons, so there are no issues. And now let's run it. As we can see, nothing is happening in the actions yet, since it's running in manual mode. Let's go into the workflow and start this workflow. The workflow is currently running. Let's actively go into it and observe the process, and wait for it to finish, monitoring the progress. Let's open the logs and take a look. All done, it finished successfully. Now let's take a look. At the step where we cache, we see that nothing was found for the cache file key. So the cache doesn't exist yet. When we try to output this code, essentially, by the way, we have it in an object, so in order to properly display this object, and effectively therefore to JSON as a result in a structured manner, we can't see this object right now. It's returning an object to us, but we can't see what that object is. After that, we install npm. We actually only have one requirement, so it got installed really quickly. In fact, in just 2 seconds. Next, a cache is created. A file of size 1 megabyte is created and saved under the name cache file. And if we summarize, let's go back up. At this stage, we don't have the cache file key. meaning it's trying to find the file by the cache file and use it. It's not there because we're running this workflow for the first time. Next, it returns an object to us, but unfortunately we can't see it. Next, it installs the node modules, and after that, it creates the cache file. This process is essential for ensuring that all necessary dependencies are properly installed and configured. Once the installation is complete, the system will proceed to create a cache file, which helps in speeding up subsequent operations. Let's run it again. This time our object should be displayed, because I pushed the functions to show the JSON object. Everything was completed successfully. Let's go in here and take a look. At this stage, when we try to access the cache file by its key, it has a result. It has 1 megabyte, just so you know, and it's already using that cache file. Next, when I try to see what's inside, it still shows me the object. Apparently, it just didn't pick up the updated workflow file and was running the previous one. Next, the installation. Notice that it's no longer 2 seconds, but 500 milliseconds, since the cache is already being used. Next, the cache is not created here because, as you can clearly see, the cache file key already exists and it is physically present, which is indeed in the system. If we open the cache tab now, we can see the file we just created. Let's run it again. And this time notice that, as expected in the display cache, we can already see this object. I ran the previous workflow, and as you can see, I already had the push on the server. But since I restarted this workflow, it seems like it used some content from its own cache from the previous workflow. However, in the current last workflow, it processed the JSON function and returned me the object that returns the step with the cache. And the step with the cache returns cache get true if the cache is found by the key, and false if the cache is not found by the key. And initially the cache didn't exist, so it returned false. Now it returns true. So, to sum up, the principle here is very simple. We set a specific key, a cache file, and it checks if there's a file with that key. If there is, it uses it under that key. If not, it lets us know, then executes all the commands and creates that key file at the end. And if it does exist, like in this case, then at the end, you just say that the cache file already exists and we don't need to create anything. Basically, this approach is valid, but there's one catch. But if it does exist, like in this case, then at the end, you just say that the cache file already exists and we don't need to create anything. Basically, this approach is valid, but there's one catch. Right now we have in the node module. Specifically, the dependencies we've installed, but as we develop the project, we keep adding things to it. Every time we add a new script or a new dependency, we'll be editing the package JSON, and that's a plus for us, because we can use it as a trigger. We can set this cache file to be not static like it is now, but dynamic, so its name changes based on the changes in package, a JSON. Leaving it as is won't update modules due to the same key. Making the key dynamic changes the name with package.log JSON updates. It won't update because the same key is being used, but if we modify this key and make it dynamic, then while working on the project, if this package.log.json file changes, which happens when we update a dependency or add a new one, this name will change dynamically. The old caches will remain and will be deleted after 7 days, and new ones will be created. Indeed, the node modules folder will always be up to date. Let's implement this right now. We're going to create this key dynamically. First of all, we can create a prefix. We're going to use the operating system as a prefix. Let's write it down. So, we can get the operating system by accessing the runner context using the OS key for the operating system. And in the end, we're going to generate some kind of ID string. So we're writing an expression. We're going to use the cache files function. And as I mentioned, we'll be tracking this package JSON. Every time we add a new dependency, it will be edited. And since it will be edited, we'll be passing it along. And if it gets edited, a unique key will be generated for it, which will be added to our file. And since this key will be added, every time it looks in the directory, it won't find that cache there, and we'll create a new one. So package.log.json. Great. We've named it dynamic. And one more thing. We can pass the restore case parameter, and it will work like this. Let's say we have some unique ID here, but if there isn't a file for it, we can set it up to look for this key. So, a file with a different ID, and for example, I used it. Right, let's take a moment to pass a few important keys to each other, ensuring that everyone has what they need to proceed smoothly and without any issues. This is a key, and indeed such a key that holds significance. Such a key, and such a key. And let's make a commitment and see what's happening with a few changes. Commit and push. Let us proceed back to our repository and enter it to start the workflow. The workflow has started. Let's check the caches. We only have access to the old file for now. We're waiting patiently for this current one to finish processing completely. Let's take a look. As it's trying hard in finding a file using its key labeled as Linux, which includes both cache files and this long value, found nothing. Next, it's trying to use that key. Found nothing. So, at the beginning of the file, then it's trying to use that key at the beginning of the file name. Didn't find anything either, because our old cache looks like this. So, it will return an empty object, meaning there's nothing, we don't have a cache. Next, it's installing everything that's needed. At this point, the system proceeds to generate a brand new cache, which is then associated with a specific key. If we take a closer look at the current state, we can observe that a new file has been created, and it is linked to this newly generated cache. This process ensures that the cache is properly assigned and managed within the system, allowing for efficient data retrieval and storage. We're running this workflow again. He has already seen this file. He actually found it by a specific key, so he didn't create a new file. If we examine in the cache, we haven't added any new files here, for example. And now let's demonstrate in our project that we're installing a new dependency. Let's assume in the console that we want to install the swiper slider. So we type npm install swiper, for instance. A new dependency has been installed. Notice that these files have been edited. Now I'm editing it in a completely new and innovative way, and then pushing it forward with determination. I am delving deeper into the specific actions that need to be taken. I'm running it again. Let's go in and see what's happening. We see it's using a cache, but not ours, as it returns false. The project needs a new cache file. With additional keys, it pulls from previous ones. It's creating a new cache with a new key due to a new plugin. Checking the files, a new cache with the plugin is created. Running it again without changes won't create new files as the ID remains the same. Added keys, using previous ones. New cache with plugin. Files show cache includes plugin. Rerun without changes, no new files. Besides that, it creates a new cache with a new key because we've added a new plugin. And if we look at the files, we see that a new cache is being created that includes this new plugin we added. If we run it again without editing anything, it won't create any new files because the ID will still be the previous one. So as we can see here, right? We go in here and see that this key is already being used because the new file, the most recent one, is present. Next, it's true here because our new cache is being used, not false like in the previous step. In the previous step, we had a file, but it wasn't our file. We basically connected it for use through the keys. And a new file isn't being created because it already exists. And no new plugins were added, so we're using this cache. And even if I launch it again, it will still use the current cache. It won't add a new file until we connect a new dependency, meaning the package file won't be changed. So, as we can see, no new files are being created here, and there are also no new files being created in the cache folder. Basically, that's what I wanted to show, demonstrate to you in this lesson.